information?
Basically, they are just similar, but in data, there is the collection of information.
Collection of information.
And the information contain the data itself and something like.
Interactive. It's like what is the first, the egg or chicken? So what do you think? Joel?
Yes. With data and information, I think data and information is similar because both of them are from the user.
So from the user point of view, right? User.
Yes, yeah, user input, all right? So I think with data, it's something that's, I don't know, confusing.
Think about the title of your subject that you have taken so far in the computer science or computer engineering. So think about yes.
So what I'm thinking is data is more like just the raw facts or results than
Data is the
like
raw data,
Yeah.
raw information.
yeah, and then once it gets maybe processed and used for something specific, then it's
When you are saying the processing means use computer,
yeah, once
Okay.
it's compiled together or put up with in a certain context, then it becomes
it
information.
has certain context. It's getting close. Think about the subject courses you took before. So like during the sophomore, pretty much you took the data structure class. We never say the information structure, right? So what is the main purpose of the data structure class?
To develop information.
Develop the information. So it's like let me paraphrase it, like the output of data structure are information, something like that. Am I true? Am I correct? Output of data structure is information.
Yeah.
That's what you are saying?
Yes.
What about the input of data structure?
Data.
It's the data. So think about when you took the data structure class first time. So you define the student, node, and the name, ID, and major, something like that. And each of them is called attribute. So this is your data. Okay. Then, for example, if you apply the sorting algorithm, like the quick sort, the bubble sort, whatever. So this is one data item. Okay. Also, when you manage if you have a number of student node, so how to organize this student, like the linked list. Use such a link to the next. This is a linked list, or sometimes you can use the step. It's a put in, push, and pop. Okay. At that time, we never say that this is information. Instead, this is data, right? So something different. Also, when you search Google, whenever you have a question or the problem, so you are using Google, right? So when you are using the Google, do you say I'm searching the data or I'm searching information? Information. Nobody says that I'm searching data. But sometimes if you are working for the company, like the accounting company, something like that, so your manager asks, why don't you bring customer information or the customer data? Which one is right away? Customer data at the time, right? So bring the customer data or last year the revenue data or your business data, something like that. So information and data are slightly different. So, but it's still the controversial. But in my class, at least in this database design class, we need to clarify what is the information, what is the data. Otherwise, sometimes it's a little bit confused. So, information looks like which one will be older concept? So considering history of natural language, information or data? Probably information, right? Even before we have a computer, before computer was invented, we have information, right? But probably there is no concept of data before. There might be, I'm not sure, I'm not the linguistic or I'm not expertise on that, but information may be older, which means information is everywhere. So student information or weather information. When you visit when you travel to the new country, you need to collect the data? No, information about that country or location. But if you are doing research on the specific country, like in Canada, you need to collect the data. So it looks like the information is not processed, it's everything, okay? Then if we collect or the sort or process such information, so we can have something meaningful information, okay? So that meaningful information we are going to define as a data. Specifically, when we are using computer, as I introduced very briefly the last class, computer is not that smart. Actually, basically, it's based on the 0 or 1 electronic signal, right? So then, however, using computer, we can store the image or video or very complicated data. How? We can organize. We can make them structured. So as computer understand such organized data, the organized structured data, then we can use such information. So from now on, in my class, the information is like everything. So like my feeling in this room is really hot, and about today is outside is chilly. But so such information and feeling and everything is the information. However, we cannot use such information in our computer system because computer cannot understand even my feeling. I need to change my feeling to, for example, temperature. Okay? Or something categorized the information like the good, bad, or the worst, like that. Okay? Such a meaningful information or the processed information will be the data. Then computer prefer the information or data. Which one is close to the computer? Data. Definitely data. So we are going to focus on such a data. However, some people believe such a processed data, even we process, this data is processed information, collected information, but sometimes we can process such a data, like for example, the machine learning, the applied algorithm, like the data structure algorithm, or for example, the data mining technique. Then we can also get the meaningful, the value of it, knowledge and intelligence, such a information. So somebody said the information also include such a processed data, output of the data structure. Okay? But we are not going to consider this, the information in this class. Instead, we are focusing on the information and the data, like such a relationship. So data is processed or collected and meaningful information. Okay? For example, in terms of data structure and the computer, so let's think about the Python. So when you are using the Python, so Python is much easier than the other program language because when you define the variable, if you don't have to specify like the string, unlike the object-oriented program, you don't have to. Their data type will be determined by the data, like the hello world. Okay, then you can print the name. So this is a very simple Python program, and then when you make the a.py file, then run the Python, then it will be executed. But the Python is different from the other program languages like the Java. So Python is an interpreter, which means it's compiled by line. While the Java will be compiled all together, then create the object file, and by linking, it will be executable file. Okay. So, however, if you learn a number of lines together, you can make the script. Then you can run a number of command or line together with using the script. Okay. So this is a Python program. So the advisor or the supervisor ask, why don't you print out something information? So this is a program, Python program, to print out the information. So this is from now on we are going to say that this is a data. So hello world data will be printed. So what happens when you learn this program? This is the memory. Okay? Any program, the computer program will be processed using form of what? The program. Okay, you should have the program. In this case, the Python is the program. And the Python has the virtual machine, specific area of the memory. Okay? Then, so this program will be loaded into the memory that will be processed. So process is a very specific and sophisticated data structure. There's a rule. So some of the area is called the text. Text is the binary code. Binary code of the Python. And you have the data area that include the global variable. Within the same process, virtual machine, this data will be accessed. Then finally you have the heap and the stack area. All of them are data structure used in the process. So when you execute any application as a program, so this process will be created on memory. Anything, any program, any process. Your application is the same thing. If you download the app is the same thing on your cell phone. iOS, macOS, Windows, Ubuntu, any operating system use the same, the architecture. You can learn more about this, the architecture on operating system. Okay, operating system is nothing but the bunch of process. Okay. Then, when you create your process or run your application, so name is what? It's a variable. So variable, the name will be created. For example, if you create the name as the empty, so this will be created. Especially nowadays, the more and more the program language is the object-oriented concept. So even C as the C++ is the object-oriented. The program language Java definitely object-oriented programming OOP, and the Python also object-oriented programming. What's the meaning of OOP? Some of you guys already took the OOP class, right? So what is the idea of the object-oriented programming?
It has classes and objects.
It has class and object. For what?
To minimize the code.
To minimize the code. That's the benefit. Then when we are saying object-oriented, which means everything is object. For what? It's the data. Okay? So data will be loaded into the memory. From the memory, we consider any data as an object. Your algorithm is an object. Your, for example, student. I remove the student. Is our data. But student is not as simple as the name. It has a number of attributes, right? Name, ID, and major. Combining this, we consider student as an object. So, Noel is an object, and the me as an object, Tanya is an object. It's an object. They have the same or the similar, the architecture, the structure. So to define the student, instead of using just the name as a string, it's a simple, but at the time we can use class. Through the class, we can create the object. This is the idea, overall idea of the object-oriented program. Okay, but Python make the simpler than Java. Okay, that is it's not exactly same concept as the Java. It's an object referenced program. It's slightly different, but we don't have to see the deep inside of that. But it's an object-oriented program. That means we are going to manage such a data as an object. So object will be created. Then when you print, so this is the input argument of the print function. Somebody already created the print function. So when you run any program, nowadays it's not easy to make the send alone the programming. You are using a lot of the library. It's sometimes a built-in library. If you do not have such a built-in library, you need to import. Okay. So when you are using Java, you use a lot of import, and the Python is also, when you import, it's some other place, definitely it's in the memory also. Okay, memory you can call their address, reference. This one also as an object, then you can use. Then the input is the name. At the time, this name will not move the entire name to here. Instead, just send reference address. Then this print function know where is the input, then get this hello world, the data, and the display. It's the overall thing. So any program language is pretty much similar. Okay, similar the process. Then problem is at this time this is simple, but I'd like to manage 100,000 the student name. How can you handle? We can create what is this? List. It's an array. Python does not have the name of array, but the list is almost the same as the array. So list is not only just one the name, but it can have a number of the element inside. So this name has the only starting point is the address. Then this one, the wrapper, the list of such a name. So reference. So name itself actually the reference, object reference. Then that address, corresponding address, has the list of data. Then we can manage a number of the data. What about not only just name? We try to manage student information like the name, address, and the ID, like that. Okay. There are a couple of different ways to manage such a number of thousands of students, including name, ID, and address. One way is you can create, as you have done in your OP class. Okay. Then for each student, you can instantiate. Instantiation means using this class. Class means what? It's a blueprint. It's a rule. Okay, it's like a frame. So using this frame, you can make a lot of the stuff. I have this frame, and you can create the same. So same student for each. Definitely, class concept of class has a lot of the flexibility and benefit, like the inheritance and encapsulation and so on. So you should learn in your programming language class. Yes. But go back to here, the class. Another way is some of the program languages support such a simplified group of data structure. Like the list, you can create the list inside the list. Okay? So like you can create a student, one, name, Lee, ID, the 111, address, the Bridgeport. And student 2, like this. Then this one will be first item, and second item, and so on. You can create the list inside the list. How? So this name, student, has a reference for the first student list, and this one has also address of this one. So using the reference address, your computer can find the data. Okay, that's doable. However, I'd like to search when I can create 1,000 of student information, student data. But I'd like to search. Eventually, we'd like to search the data, search the student using ID. How can you? You need to visit all first student and going to the ID and check whether 111 or not. If not, going to next until you find the data. It works when you have the 1,000. 1,000 may not be really big number, so you can get. However, what if you have the millions of student information, student data? It takes longer time. Okay. Also, sometimes if you are lucky, you can find the data first. But sometimes if you are not lucky, it will be last one. So you cannot guarantee how long it takes to find the data. To address that problem, some data structure support search by key. So for example, dictionary in Python. If you do not know the Python program, don't worry. Okay, it's not Python class. I just like to give you the example. Okay, just sample. Look, even you can implement such a data structure using other program languages. But we can, for example, dictionary has the key and value. So you can always find the value using the key. Inside, we don't know how they search. Probably they will search the one by one, okay? Then the return, but from me. So we don't have to worry about to check the each and everything. Just search by the key. So when you return, so you can give the key, then the output will be the value that corresponds, that match to the key. But what if we have the same thing, the millions? So we can create millions of the reference here. So for example, if the one student take the name is 100, the address is another 100 byte, and the ID is the 50 byte. So let's say the 250 byte for each student. If you have the millions of that, how much bit? So 250 byte multiplied by the million, it will be 250 million megabyte. Okay? 1 megabyte, 1 million, 250. Okay? The megabyte. So that means in the memory, we need at least 250 megabyte. And also it takes some time. What if 10 million of data? It will be easily 2 gigabyte memory we need. So this approach is called, last time I mentioned, memory-based data management. Okay? But memory-based data we have been using a lot from the program languages. Whenever you learn the first program language, you learn the hello world, right? In the Java, the system out the print hello world, and Python print hello world. And any program language you start with this hello world. At the time, this hello world itself is a data. Then is managed within the memory because of the nature of the process. Process is the memory structure. Any program you code and run is on the memory, but it's limited. When we have very large data, like the million and trillions of the data. So, when you have the small amount of data, you can continue to use your program language. Sometimes we can create. So memory is volatile. You may lose your data without power. At that time, you can save this data to the web file system. You can write the file, and keep this data, the file system. And next time you can read. Still, the main part of the management for the data is memory. So memory based. The main problem of this one is limited by the size. And also same time performance will be the reduced, the downgrade. Okay? You learned a lot. With the big notation and the data structure and advanced data structure class. So sometimes, for example, linked list is OO, N. The more data you have, the longer time it takes, right? Do you remember? No? Doubly linked list and the singly linked list and stack and so on. So these are the basic data structure for what? Memory based. But still limited. So when we have the very large data, we cannot use the memory. So at that time, we need to think about the new data structure. Not in the memory, not in the file as a separate data structure in the permanent storage. This is called the database. So, long time before, before the 1970, it was okay to make the data in the memory or with the file. But as business was grown up and the size of data is bigger and bigger, then they felt at the time 1960, 1970, at the time people and who were managing the data, they felt their system is not good enough, not big enough. So we need to find a different way. One solution is you can purchase the better CPU, bigger memory, and so on. Think about the 1960, 1970. What's the size of the memory? 1 megabyte? No. Even I had the first personal computer 1983. So right after Apple, Steve Jobs was in the Apple, then he released the Apple II computer. It's the 16-bit computer, first 16-bit computer, but he was kicked out because business was not good. But he came back, then the success in the iPhone and iPod, then followed by the iPad, iPhone, and so on. So when I used the first personal computer, it's the 16-bit, and then at that time the memory size is 1 megabyte. So I cannot load the entire operating system. So at that time I should use, I'm not sure whether you know the floppy disk. I should plug in the floppy disk, external, the drive, to start the operating system because memory size is not big enough like that. So we cannot, at the time, the people cannot use the memory-based data structure for very large data. So at that time, Dr. E.F. Code and the other from the IBM T.J. Watson Research Center. This T.J. Watson. The T.J. Watson is one of the most popular researcher in database area, the computer science area. So he was from IBM. Still, IBM used the name of the Watson. So for Watson Computer, Watson Research Center, and Watson. Then he worked for the IBM at the time. He developed a new idea how to manage very large data. So that is starting from the database model. So at the time, so data is changed to the database. So database means what? It's a collection of data. When we have a lot of data, large amount of data, it's called a database. Okay, like the storage. So database, but we need to organize. Think about the, as I gave you the example, 7-Eleven convenience store and the Costco or the BJ, the wholesale center. Do they use the same mechanism, same process to manage the stock and the item? It's the same? Maybe different. If you go to the Costco, the Milford, Costco, they stack up the whole bunch of the item. But the 7-Eleven is a convenience store. They actually put the less amount, but the variety of them. So they use the different approach to manage such as their item. Same thing. When we have the very large amount of data, that is database, we need to different organization, different data structure. That is called the modeling. So they start from the database model, different way to manage the data. So this, the database model proposed by the Dr. E.F. Cole is called the relational database model. Have you ever heard about the relational model? Relation. Or sometimes it's called the RDB. Relational model, RDB, is like the Oracle, Informix, DB2, SQL Server, MySQL, and the CPSC. Those are popular relational database software. So he proposed a relational database model. Idea is a simple, really simple. Until this time, still when you are using the memory-based, the data management or the program language, data itself is considered as the object, data by data. Okay? Individually, for each object has their own reference, their own structure, their own storage. So for example, even though we are using classes to standardize, so we can inherit, we can change the class like that. However, on the other hand, in the relational model, the idea of to manage such a very large amount of data is simple, just standardize. Okay? So for example, if you go to the Costco, have you been to Costco? At the wholesale store. What else? So Walmart wholesale. So BJ is a wholesale, and the Costco is a wholesale, and I forgot the name of the Walmart. But if you go to the wholesale, the
Sam's
market,
Club.
Sam's Club. Yeah, Sam's Club. They actually stack up. Any item is like the stack up, because they need. If they have the different package, different size, it's very hard to manage. Okay? Using the forklift, they can just stack up such an item. Is the computer is the same pack, like this part, and the refrigerator is the same size. It's the same size, stack up, and this one. It's a standardized. Then no matter what type of the package they have, so they have such as the same pallet style, the package and manage. Similarly, when we manage the large amount of data, we can standardize such a data. So, for example, student, in case of a student, when we have a lot of students, so first decide what is the important information, like the name, ID, GPA. These are the important. Even though his grade is the sophomore, I don't care, okay? Because it's not important for me to manage the student information in this class. Only GPA is important. Who decide? When I design the database, I decide. Okay? And even the Tanya, he likes the sport, but I don't care. That's the information, but it's not important information in my class. So the rule is name, ID, and GPA. These three information are important. Then define the student as name, ID, and GPA. So any information in this model is a name, ID, and GPA. Then managed in the permanent storage. So this is called the relational database model. Then if somebody used this concept modeling for the software, that is called the database management system, DBMS, like the Oracle, Informix, DB2. They are using the same concept. So it's not a big deal. So in my class, as I announced, we are going to use the MySQL using the cloud computing environment. But what if when I got a job offer from a company, they use the different DBMS, like the SQL Server. Any difference? Almost the same. Because they are using the same data structure, same concept. So it's not much different. So in this class, we are going to learn what is the relational database model and what is the relational database management system, how to use such a relational database management system. Okay? Then to do that, you need to practice with a real problem. For such a problem, in your project, you are going to create the registration, UV registration, the database. Design. First, you are going to design, then modeling, then create the database. Then from the application, access this one. This is the overall thing in this semester. Okay? So we talk about a lot of things. Then quickly, any questions so far? So this is the summary of what we have discussed so far. So what is a database? It's a collection of data. But you can see the adjective related. Okay? We don't want to put the student together with professor. So professor, it's not important GPA, right? So we try to collect the related data, standardized data, that is called the database. Then, as we discussed a lot, the data is non-fact or the important and thus or such the meaningful information that is called the data. Okay? Then if the company implement, or you can also implement the software based on such a database that is called the DBMS. So DBMS is the software. Okay? Like the Microsoft Word or Excel or the app on your cell phone is a software. Based on what? Relational database model. Then if you create your own database using DBMS, that is called the database system. Our goal, the final goal of this class is you are able to create your own database system. Okay? So it can be used a lot. Still, as I introduced the last class here, as you can see, the database everywhere is a really big pie in the market. So a lot of the student in this room will join the IT company or as a software engineer. So there's no the software engineering project without database as a backend. Because data is getting bigger and important, definitely they should manage such a data. Then how? At the time we can use the database system. Okay. But nowadays it's slightly changing. So until the 5-6 years before, like the 2010, so relational database here, relational database is everything, only the relational database in the market. But once we have the big data, so you heard about the big data. Big data is big data, okay? So size of data. This was invented, proposed 1970. Even 1970 at the time, one of the main problem was the size of data. So Dr. E.F. Cote proposed relational database. Then 40 years later, the size, the scale of size is totally different. At that time, it's a megabyte level, but 2010, 2020, right now, it's even exabyte. I don't know how many zero in exabyte, but it's huge, really. Even think about your cell phone. Anyone who has a 1 gig, the memory size, nobody. At least the 4 gig, the 8 gig, but nowadays 16 gig, and some of the Android phone allow the external, it's almost terabyte level that you have. Even personal computer is a terabyte level. Company is much bigger, okay? But I worked for the bank before I moved to United States. It's 1996 to the 2002. I worked as a database administrator. So I managed such a relational database. So 1997, my company decided to purchase the storage because the business was going well, so they decided to extend the size of the storage, size of the database. So one of the popular still, it is the top company in the storage market was the EMC. So EMC is still here. So we purchased a storage box. So EMC, its total size was 72 gigabyte. Do you know how much was it at the time? It's 3 times of my yearly salary at the time. The 72 gigabyte storage box, 1997. Unfortunately, even we cannot use the entire 72 gigabyte because it's required to meter. When you meter, you can use only half of the storage. So capacity was 32.6 gigabyte. It's around the 250K, the US dollar at the time. So it's almost 25 years before. Then there is a 250K price US dollar for the 36 gigabyte. It was the RAM. It's a small, so relational database was okay. Not small, but once we have the bigger size of data, we need to think about different approach. The relational database model is not good enough. So nowadays we have the NoSQL database. NoSQL database is non-relational database model. As you can see, relational database model is still most popular and the most market share, the database model, but more and more NoSQL database. We do not have enough time to talk about the NoSQL database. Later, if you are interested in more about such an advanced part of database, I offer the NoSQL database, the class, hopefully next semester that you can take. So then finally we understand such a need. Okay, so this is the overview of how database system is organized. So DBMS is like the MySQL software. Then using this DBMS, we are going to design and create the database. And after we create the database system from the user, in other words, application, your program, should be able to access such a data. In the memory-based program application, your program, and the data are in the same data structure. So it's easy to access using the address, right? Reference, object. However, in the database system, data is separate. It's in the permanent storage with a different model, different data structure. So because of that, it's called sometimes back end. This part is called front end. So front end focused on application and application logic. But on the other hand, back end database part for the managing data. Okay. So our goal of the this class is the back end part. But without front end, so we cannot see the benefit of the using backenders. That is the reason in your project you should be able to access the data using your application program. So if you believe that you are not very confident the programming, it's a good time to practice. It's not programming class, but you should be able to. So finally, what is the main? So we know what is the database and what is the database system, what is the database model. Then at the time, so what we can do? What is the functionality of such a database or the DBMS? First, go back to the data structure class. So how many of you do not take the data structure class before? You didn't? Please read. That's very important. I know that some of the graduate students also changed the major, so didn't take the data structure class. I believe the data structure is the most important, even nowadays. So I heard a lot from the hiring department and the recruiter. They usually ask the data structure related question when they have interview. It's true, Tanya?
Yeah.
Right? I did the interview the last time. It's really true. The data structure related is the most popular and from the data structure class, like the incremental oversort. So can you do that? So like using the step, something, the data like that. So when you took the data structure class, there are 4 operations. Do you remember using data? Do you remember what operation? Read, right? You can read the data. That's our main purpose. Read and write. Create, right? Write is create, and also sometimes you can change the value, update, and delete. It's called the CRUD operation. CRUD, create, read, update, delete is the 4 basic operations. Sometimes the update is delete and create. Okay? You can delete and create, that is the update, but update is separated, so CRUD. Database use the same functionality. Basic. It's a basic operation. So retrieve. Database use different name of read. Okay? Information. When we are searching the information, we are saying information retriever. Like that. So database use sometimes a retriever, but mostly we call it query. Okay? Not search. So instead the database use the query, but same meaning. So to retrieve the data. Query is the database terminology. And modification, insert and delete. So insert, delete, and update are implemented in the database. So these 4 operations are also basic operations in the database management system. So you can do the CRUD. Okay? But not only this one, the database also supports data structure, like the class. So it's not called the class, it's not called the construct, instead it's the database structure. For example, later we will see table. Did you hear about the name of a table? So when you are using the database, probably you will be asked, why don't you create the student table? Well, why don't you create the professor table? Like the table is such a construct. It's a model data structure to keep the data. Okay? These are the very basic, but not only that. Think about when you create the Java programming. So you can update, you can delete, you can insert the data, right? Using when you define the student class, you can create a constructor, default constructor, and your own constructor, like the basic. The constructor is the method that is a read, write, update. Why? Because you want to hide, right? is abstraction. To implement the abstraction, you can create such a thing. But what if your friend wanna access your program? What if your friend run the same program? Is it the same data? It's a different process. You cannot share. If you wanna share such a data, one possible way is you can create a thread. But at the time, so you have the global variable, so each thread can access the data like the GPA. Can you guarantee such a global variable? No. So your friend increase the GPA, but you decrease subtract the GPA. So we cannot guarantee such the final value of the global variable. That is the reason global variable is not the recommended to be used in your program, which is called what? Synchronization problem. So if you are taking operating system, so synchronization is the big issue. So it's a mostly single user, but if you support the multiple user, multiple thread, you need to think about such a synchronization problem. Database address such the problem. Database is not only for the single user, it's a multiple user. So how can we address such a problem? Using transaction. So we will talk about the transaction on second half of the semester also. Then the DBMS support much more, like the security and the maintenance, backup and recovery, and so on. So later we will, after we complete the first part of the semester, like the database design, then we will talk about such a functionality of the DBMS. This is our goal. In your project, you wanna do what? Create the registration database system. This is a university with the example of the database system. University database, it consists of the student course section. It's important information. Somebody decide these are the important information. Then what we need to do is design student modeling. Okay, that fit to the relational database model. That's what we're gonna do. So at the end of the semester, you should be able to create such a database. This is an example. It looks like the tablet style. It's called a table. So number of a table. Course table has the course name and the course number, credit hour, and department. Each of them is the data, okay, which is called the instance. A number of instances. And section is the attribute and the number of instances. So this is called the database that you are going to create at that time. So this is called, later I will introduce one more time. The attribute, so this attribute is called the schema in database concept. The schema, so in the project, in the registration system, you should create the schema for registration system. This is a schema for university. Then by following the schema, we can insert the data. So such a data is called instance. So by combining schema and instance, like this database is called the database state. So if you create such a one database state, that's done for the database, the design and the creation. Okay. So I try to introduce the idea idea of why we need the database design and comparing with the memory-based database. And finally, so any benefit of using the database approach? So this is the main characteristic of the using database. Comparing to the memory base. Memory base may not have. They may have, but it's not the fully supported. So when you are using the database, first the benefit is the self-describing nature. Self-describing nature means somebody criticized, I can do the similar, such as schema and instance using class. Okay? So we have this one. So what if once you create the this is instead of this one. Let me compare with the 5. So in your programming class, you can create the content, that txt file. Then open the file, then store the 4796, the phone number, and James 1111. So you can write the data and close. Then you can keep the data using this contact information. The problem of using this file to keep the data, to manage the data is sometimes I add address here. Sometimes James does not have address. Sometimes 112, this is a pattern like that. We don't know what is the phone number, what is the name, what is the this. Your application program should know everything, right? If somebody change, you need to change the application. However, if you are using database, when we create the relational database, it's kind of standardized. So like using the schema. This schema information is in the also database. So you don't have to worry about what is the, for example, the attribute, course name, course number, and so on. You don't have to worry about it. It's already in the database. That database is called the catalog database. So all relational database manage the database for database information. That's called the catalog database. Okay? It's not real data. Instead, it's the data for database. Okay? Sometimes it's called the metadata information. Okay? So this is called the catalog database. So catalog database is very useful to manage such as standardize, the design the database. So in other words, if you wanna, I don't know much about the university database. So I'd like to know how university database is organized. At that time, you can access the catalog database. Then it shows what is the name of a table, what is the attribute, what is the data type, and what is the size, and everything. Okay? So you don't have to, it's kind of the housekeeping job. So you don't have to worry about such a metadata housekeeping job, because database, relational database itself manage such a data as a format of database. It's another type of data. Also, database system provide such a insulation. Insulation or abstraction. Next one is abstraction. It's very similar. So what is the meaning of insulation? Insulate means it's a protect block between one, program and data. So for example, if you change the format of this file, you need to change your contact.c file. Okay? You need to, or the Java file. You need to change your source code. If you change the order of your data, like the ID first followed by the name, you need to change your code, right? So your program depends on your data structure. However, in the database, if you are using the database, what you need to know is, I'd like to know name of student. So if you know the student table name and name of student, you are able to access. Because even though database changes the location of the table, student table here and there, and their format, doesn't matter, because you don't have to worry about. Database is in charge of such a structure. So it's a separation of the program and the database. It's an insulation. So insulation between the program and the data make us easier to manage the application. Okay, so that is the insulation. And abstraction, you heard about a lot, the abstraction level. Abstract means what? Hide behind. To simplify the application. So using the model, so we can hide the behind. Like for example, we don't have to worry about how data is stored in the database. Abstract. It's who is in charge of such a thing. Database manufacturer, Oracle company, or the MySQL company, they should provide a way to physically how to store the data. We don't have to worry about it. It's the abstraction. And also another benefit of using the data is multiple view of the data. For example, we have a student table. Finally, we create a student table. But not only computer science department who need the student information, but HR or the register office, they need student data. So they create their own, the student table. And the HR department create their own. And the security office create the student data, their own. What happened? So all different. So for example, if you move in the apartment, you need to inform to security, HR, and here and there, right? So instead, we can create the one student table using the multiple transaction. So we can provide the permission to the HR. But HR needs social security number only. And give the permission to the CSE department advisor and profile and GPA information. Security need to know their student ID only, like that. Only one table but different view of the table that can be supported by the DBMS system, which is called the multiple. You don't have to create the same information but different table. Instead, one table but can be used a different way. And definitely support the multiple transaction and so on. So this is the DBMS. I spend a lot of time to introduce what is the database. It's a different approach to manage the data. Well, so what is the advantage? We already discussed. So you can go ahead. But the interesting is, so database solution is always the best solution. It's really happened. When I work for the company as a database administrator, nowadays it's much better, but 20 years ago, I cannot find really the DBA job. So I was a rare case. So sometimes small, medium-sized company who manage their own data using the DBMS, they do not have a database administrator. Okay? Nobody knows. Once they start a new project, then nobody take care. But year by year later, their system is slow and slow. So from time to time, I was invited and as a consultant and work for such a small company to manage. Whether it's like the clean up the room. So I checked their database. Surprisingly, one of the small company, they spent around, I think at the time, almost $0.34 million per year to pay for their maintenance fee and the database so on to the Oracle. Oracle was not cheap even the 25 years ago. Then when I checked the total size of data, it's 150, less than 200 megabytes at the time. At the time, 200 megabytes is not the small, but still it's overpaid. They don't have to actually create the database and manage such a 200 megabyte data using Oracle database. Instead, they can even use the file system. Their application was really simple. It's simpler than UB registration system. It's just customer information. Instead, they can separate the customer information by the file. Even text file is okay. Then manage it manually. Then pay for the operation fee or labor fee. That will be much, much simpler. Even then they can back up, but they overpay. It's just too small. So when you have the small amount of data, the database is not the good solution. Even though you are able to use open source, the DBMS, it's free to use, like the MySQL, but somebody should manage. You need to pay for the maintenance fee. Even though you are using cloud computing, cloud is not free. For educational purpose, you can use the cloud computing resource with a free coupon. But after graduation, your company or if you build a startup company, you need to pay for that. It's not free service. So when you have the small amount of data, you don't have to overpay to manage such a small amount of data. Instead, you can find nowadays the in-house the data management or even you can use the Microsoft Excel or Access. That will be easier and cheaper, even secure. Okay, so that is the one thing you need to keep in mind. Database is not the best solution always. So when you have the small amount of data, so it is saying that, generally saying that if you have the over gigabyte up to the petabyte, several petabyte size data, relational database is a good solution. So most of case. But if your company is a really big company like Uber or Amazon, definitely you need to consider different way. The relational database cannot cover the 100 petabyte size data. At that time, you need to consider the different database system like the NoSQL database. But if you have the small amount of data, several hundred megabyte, so DBMS is the overpay and the overload. Okay, so too much pay your Apple. So that is the end of chapter 1. Any questions so far? Then chapter 2 is the concept for the database. I already explained most of the thing. So I'm going to little bit speed up. If I cannot finish the chapter 2 within 5 minutes, so I can spend a little bit more time next week. Okay. So what is the database model? Here. So what is the model? So you always probably you always use I need to model the problem or the modeling and software engineering and the object-oriented programming. You need to do the modeling. What is the modeling, by the way? What's your name? Yeah. What do you think? What is the modeling? You have used it. Name of modeling, right? In your class. Not sure. What about the supermodel? Fashion model. So if you are a designer, so you definitely hire the model, right? So which one is better? The handsome guy or the beautiful woman, or who is the best supermodel in fashion industry? To show the design the clothes like that. To do that, it's a standardized. So usually the supermodel is not the most handsome guy or the beautiful woman. Instead, their body structure is standardized to show up the best the output of the design. So similarly, in the data model, when we talk about the modeling in computer science, modeling means standardized. Otherwise, if not model or non-standardized, computer cannot understand. As I keep saying, computer is a simple 0 or 1. It's an organization of the 0 or 1, which means standardized. Otherwise, computer cannot definitely understand what you are asking, what you want. Instead, standardized. That is the model. Okay. So, but different way of model. There are a bunch of different way of the software model, hardware model, and something model. So among them, we are going to use relational model. Okay. So there are you will hear a lot of different modeling. That usually modeling, or another popular one is object-oriented model. So when you analyze the data, you apply object-oriented concept. That is the object-oriented model. So when you design, like for example, class include what? data and method, attribute and behavior, the data. So two parts, data variable and operation. So it's the same thing for any types of the modeling in computer science. So structure is the data and operation. So you need to think about the relational database, so it's the same thing. Relational model has such a data structure and the operation. So we are going to focus on that part when we model our data. There are different types of model in database. It's a conceptual model and physical model. Ignore implementation, what's this one next to. So author of this textbook, Dr. Almasari, prefer to add the data model. So I think the more important thing is the first two, conceptual level model and physical level model. So our database model is starting from the conceptual level. Conceptual level means simply ignore computer stuff. Okay? So if you are asked by your supervisor, why don't you model the NASDAQ stock market trading, the database? What is the first step to model to design the NASDAQ? You need to understand how stock is traded and how such a business is organized, right? Instead of what? Programming. So you should have expertise on that data domain. So that you can organize the data conceptually, not physically, not database, not computer. So that is called the conceptual level design. Then physical level design is focusing on the computer. Then you try to, if somebody organized the model for the NASDAQ, then I try to apply this model to the database using computer. That's different story, right? How? Like using object-oriented concept or using table like that. That is called the physical database model. So sometimes when you search the job, your job description mention about 3 years of the conceptual model experience or 4 years of physical level experience like that. So in this class, we are going to focus on both conceptual level design and physical level database design. So conceptual level is the first step. Next class, we are going to start right away conceptual level the design. Okay? Then followed by physical level design. Then finally, you can implement something that is implementation. You don't have to worry about. So these two you need to keep in mind. For the conceptual level design, we are going to use the ER modeling, not object-oriented model. Okay? So you heard about the ER model or Irwin or the entity relationship model. We are going to use that. And the physical database model, it depends on the DBMS, but it's based on the relational database model, we will see. The last, I already mentioned about the schema. Our output of such a design will be database schema, description of your database, our model. Okay? Then, finally, it will be represented as the diagram. This is the database schema diagram. So, this is the output of conceptual level design, then physical level design. Okay? More complicated, it's simplified, the diagram. So if you can do the diagram from the information, then that's done. Okay? Let me stop here. Then, last question. I'm going to continue a little bit more about the concept of the database next class. Then we'll start conceptual level design first, ER modeling. Okay, before that, for the project, I have the 10 students in this class, the 9 plus the online student. So we can do the group project, group by 2, then you can add more effort and more functionality. Okay? So what do you think? Do you like the individual or the group by 2? What do you think? No idea? So let's decide the next class. Okay, why don't you think about the project formation? whether you like the group, or it can be doable. For undergraduate student, it can be the group by two. Then the graduate student is individual project. Okay. So we will see we will decide the next class.